once you become comfortable with the distance formula, they usually jump and they'll ask you to find a missing coordinate. So I don't have two full-blown points. I have one point and a partial point, but they give me the distance. When I go to solve this, I obviously will start with my formula. Distance is equal to the square root of delta x squared plus delta y squared. And when we do our deltas, to go from 3 to 5, clearly we're adding 2. But when you have a variable in place, really what you have to do is look at doing a subtraction here. And when you do your subtraction, it would be 2 minus x. It's just like when I'm looking on the y's here, 5 minus 3 is what gives me 2. Now, I can actually write these either way. So if you write 2 minus x and you don't like the way that looks, before I even do this, I'm going to restart the problem. I'm going to show you that the order of the points does not matter. I think most of you would like to see your variable first on this. So when I go 5 to 3, that's a minus 2. I've dropped down by 2. But on this, as I was saying a moment ago with your variable, it's always going to be the second coordinate minus the first. So I'd go x minus 2. This is actually an x minus 2. Now as I plug these into the formula, I have a distance of 7. So we'll come back up here. I'll say 7 is equal to. Now my delta x is this x minus 2. So I'm just going to treat it like an algebra problem. X minus 2 y squared. And then my delta y on this one was negative 2. So I'll say plus negative 2 squared. As I said in the last example, you got to make sure that you do your squares first. So as we square this, we're just going to FOIL it. I got 7 is equal to, if I FOIL this, now I'm a little more versed than you guys, but I can FOIL in my head. That'd be x squared minus 4x plus 4. So I'm just on the full-blown FOIL there. First with first, outer, outer, inner, inner, last, last. And negative 2 squared is 4. And that's all under a radical. So I simplify what I'm looking at. 7 is equal to the square root of x squared minus 4x plus 8. Now at this point, I'm pretty much stuck. So the only thing I can do is square both sides. If you square a radical, you will destroy that radical. You'll take that radical away. So I'm going to square both sides. 7 squared is 49. And as I square this radical, the radical will disappear. What's left inside there, known as the radicand, is going to be brought straight down unchanged. And this actually leads us to a new idea. It's built off of an old one. I need to zero this out. So I'm going to move the 49 over. As I move that 49 over, I get 0 equaling x squared minus 4x. Now it comes over as a negative 49. 8 minus 49 is negative 41. I'm pretty sure that I can't factor that just using our traditional methods. So I want to show you a little bit of a cheat. One of the things we can do at this point, we can go to our Y editor and we can type in this expression for our Y equation. So what I'm going to do is I'm going to type in x squared minus 4x minus 41, and I'm going to graph it. If you recall earlier in the year, I showed you how to do problems using technology. We were talking about linear functions, and what we were interested in is where it was crossing the x-axis. This is no different. So I'm going to use the exact same technique that I taught you before. I'm going to go second, calc, and I'm looking for that 0. These zeros will be the solution to the problem. So I'll do my 0. Now I'll have to do a left bound, so I'm going to start all the way over here on the left. I know it's going to be negative something. See how it goes from a positive to a negative. I'm looking at the y value now. I have to be above the x-axis. I'll move to the right. I'm beneath the x-axis. I hit enter. It asks for a guess, and it'll take me to this value. It tells me that my first solution would be x equaling, we'll keep it to 2 decimal places. It says negative 4.71. Negative 4.71. Now I've got to find this other 0. So I'm simply going to go second calc, do my 0 option. I have to move to the right, get pretty close there. Now in this situation, I see that I'm going to have to go from negative to positive. So I start here at a negative value. I move to the right until that y value goes positive. I hit enter, do a guess, boom, it gives me a value. This time, 2 decimal places, it's telling me x will equal 8.71. And you'd want to list these as a finite set. Finite set simply means you list both answers that you have, least to greatest. So you say negative 4.71, comma, 8.71. There's my list of answers. Now that's how to do the distance formula, or use the distance formula to find a missing coordinate. And you say, wait a second, how can I have 2 different answers? Well, if you're looking at this graphically, you could have, I'll just do a quick sketch of this here. We'll say that 2, 5 is like right here. And then I knew that the other solution had a value of 3. So let's say this y value right here is 3. It's got to be somewhere on this line, but 7 units apart from this point. So that could happen either over here or over here. And that's essentially what you're finding. And when you look at this, hopefully this makes sense. If it's telling me negative 4.71, that would be here, and 8.7, that would be over to the right. And both of those would have a distance of 7 units because the delta y has already been established. You just had to figure out this distance. Right? And that's how I originally started the problem, where when I was speaking I said I could write this as 2 minus x, and then I chose to rewrite it so where I could have x minus 2 because you guys are more comfortable seeing your variable first. Either way would find those 2 values because you're going either direction, and when you square it and go through that whole process, it doesn't matter which setup you used, it would still lead you to these exact same 2 answers. Now I'll do a second example of this here. That'll be example 4 in our video series.